Okay, so in this video I'm going to be showing you how to do a statistical test called a t-test for those who weren't able to follow the procedure in the textbook. Now, a t-test is designed to see if there is any significant difference between two independent sets of data. It might well be that any differences are down to chance. At what point do you say, okay, well, the differences are down to chance, or no, there is a big enough difference that the factor we are investigating has definitely had an effect? We do a t-test. So the vehicle I'm going to use to show this t-test is something that a few of you I know are familiar with, which is computer gaming. I'm going to do this through World of Warcraft. Now, I'm on a test realm here, this isn't a live realm, and there's a new ability we've got which does two things. For 30 seconds I get a flat 20% damage increase, just has always been there. And there's an extra benefit. For 10 seconds I get a stacking damage buff. Now there's some people on forums saying that the stacking damage buff doesn't seem to be working, even though the tooltip shows that it's happening. So I did a few tests to see if it was, and I thought, well, actually, I think it's working because I'm getting more damage when I'm using this stacking buff than when I'm not. But that's not proof. You can't just look at two sets of data and say, well, one's bigger than the other, therefore it must be doing something. So I'm going to carry out a t-test. Now, for this test, I'm going to use the same damage ability, which is the yellow hammer you see descending from the sky there. I'm going to do it 10 times with the stacking debuff active, and I'm going to do it 10 times without the stacking debuff active. For the full duration of the hammer in both sets of data, I'm still going to have the 20% damage buff active, which is indicated on that icon there, to keep things equal. Now, when you get to the end of your own t-test, you will be asked to evaluate whether the test was valid or not. Now, of course, the t-test is a perfectly valid test to do. But of course, if anything can affect your data, that might make the test or the conclusions you draw as a result of the test invalid. So are there any things that can affect this test? Well, I've already taken account of one thing. I've still got the 20% damage buff active for both sets of data, so that's the same. Damage abilities, for those who are familiar with online gaming or computer game in general, you'll know can get critical values where it will just randomly do extra damage. By doing it 10 times, having a reasonable sample size, hopefully we'll get roughly the same number of critical strikes, the extra damage. But one way of telling this is when we actually start to work out our mean averages and standard deviations. If we compare the standard deviations for both sets of results, if the standard deviation is in simple terms a measure of the spread of data, if they're very close together, it implies that one wasn't luckier than the other. So we're okay to go with the t-test. So we'll keep an eye on that for later on. So once you've got your data in a table like this, to calculate a t-value, of course, we need a mean average for both sets of data, and we need a standard deviation for both sets of data. Now I'm just going to go ahead and do the mean average here nice and easily. Anyone at this level should be able to calculate a mean average easily enough. It's add up all the values, divide by how many there are, and I've got 10 sets of data in each set. Now, the standard deviation, you could just do that. I'm using Excel. I could just use the Excel function to calculate standard deviation, but that's not how you need to do it. So I'm just going to put in these other two columns here, which you can see. So in the first column, we have each value minus the mean average, and then the next column, we square that. And then when we've done that, we get to the end of each of those columns. We'll put all that data in. We'll need to square root, well, we work out an average first of all, sorry, and then we're going to square root that, and that gets us our standard deviation. And we're going to do that for both sets of data. Once we've got a mean average and a standard deviation for both sets of independent data, we need to plug in the values into the equation for the t-value, and that's shown here. It looks a little bit horrendous. If you do it in bits, it's much easier. So first of all, work out the difference between the mean averages. Put that to one side. Then work out one part of the bottom there. So you could work out, for example, the standard deviation 1 squared, divide it by how many values there are, 10 in my case. put that to one side, then work out the square of the other standard deviation. Again, I'm going to divide by 10, that's how many values I've got. Put that to one side, add those two up, square root them, and then do the difference between the mean averages divided by that number you've put aside, and that will get you your t-value. Okay, so what do we then do with this t-value? Well, we need a table of critical values. Now, the table of critical values has a number of values across the right. It's our to do with our confidence limits. If we want to be 95% confident, we're looking for p as being a 5% error. Or we're okay with a 5% error. So we're going to look down that column. Now, down the left-hand column, you'll see degrees of freedom. What are the degrees of freedom? Well, for a data set, your degrees of freedom are how many values you've got minus 1. But we've got 2 sets of values, so we need to add up all the values we've got and then minus 2. So we've got 20 sets of values altogether, 10 in each. I'm going to minus 2 from that to get 18. So 18 degrees of freedom at p equals 0.05. Read across to that to get the critical value. Now, when we're doing a t-test, we always have what's called a null hypothesis. The null hypothesis always states that there is no statistically significant difference between the 2 sets of data. It states that if there is any difference at all, it's purely down to chance natural variation. So what we do is we compare our t-value to the critical value. If our t-value is equal to or less than that critical value, then the null hypothesis is supported. In other words, any difference is just purely down to chance. However, if our t-value is greater than the critical value, then there is a significant difference and we reject the null hypothesis. We say that actually the factor we were investigating has had a significant effect. And in my particular case, it would mean that the stacking buff is active, as I suspected it was. So what I'm going to do is I'm going to compare my t-value to the critical value. So my t-value is 3.6 and the critical value is 2.1. So my t-value is greater than my critical value, which means I am rejecting the null hypothesis, and I am basically saying that that stacking debuff is definitely there, and I was right. I usually am.